Okay, so this bellwork stuff, I threw it into the assignment because I just really wanted you to see the difference between factoring and solving. So one of them says factor, the other one says solve, and they mean different things. When we factor, we're basically rewriting the problem so it looks different. It's not actually like an answer like x equals, it's just a different way of writing the problem. Now, did you guys all recognize what type of problem this is? From the list of 6 that we should know? What kind is it? It's a difference of squares, perfect. So we know that a difference of squares has this pattern where you can split it up into 2 parentheses, square root each part, make a second copy, and then just put a plus and a minus. Now, I put it also in this set of notes is because tomorrow you're also going to have to factor. So it's coming back, like I promised. And so for question 1, that's the answer. That's all you could do. So in problem 2, it's a little bit different. Now, if you just look at how the problem is set up, problem 2 actually has an equal sign. Problem 1 didn't have one. That's why we can't solve it, because there's no equal sign. So in problem 2, now we can actually solve it using like our old math skills that we were used to. Like hold on. We're going to try to do the stuff like get x by itself and all that stuff, just like we used to. So to get the x by itself, we could add 81. So then this would cross out, and then we would be left with x squared equals 81. And then our final step, do you guys even know? Like, how would you get the x so it's all by itself and it doesn't have the little 2? Yeah, the opposite of square is square root. So we would square root this side, and we would square root this side. Now, most people, when they solve these, they say that the answer is 9, which is kind of correct, but it's only half the answer. Because you got to think back to what a solution is. Isn't a solution something to where we can go back and plug it in, and it's going to create a true statement, right? If I plug in 9, 9 squared is 81, and then if I take away 81, it gives me 0, so it actually works. But what a lot of people forget is that when you square something, no matter what the number is, it's going to turn it into a positive. So what a lot of people forget is there's actually 2 possible answers that you can put in for x squared. You can put in a positive 9, or you can put in a negative 9. So what we do is we just put plus or minus. So anytime you square root something, you have to put the plus and minus to account for the fact that 2 numbers would actually work when you go back and plug it in. Now, the thing about this bellwork question right here, once we have that solution, that's basically what I need to teach you for today. Today's lesson is how to solve for x in these problems that we call them the square root method. They look a certain way. So if you guys take a look right here, it says method number 1. I told you guys that in this chapter, I'm going to teach you like 4 different ways to solve problems. And it's all going to depend on how the problem looks. So the first thing I'm going to do is just kind of identify what these problems look like. What do they look like when we have to use the square root method? By the way, we call it the square root method because our last step is to always take the square root. So these problems, oops, I don't know where the highlighter came from. Let me undo that. These problems, they're going to look a certain way. So these problems, they only have an x squared term. So what I mean by that is you could have multiple x's, it's just that all of them are going to have the x function. So you won't see anything like x squared plus 4x. That's not this type of problem. That's going to be a different method. So these problems will only have the x squared term. And if you think about what we learned yesterday, it is possible to end up with an I in your answer. So you could get the plus and minus, like let's say 2i or something like that. That's why we had to learn that stuff yesterday about the imaginary number so we can fix our square roots. So the way we solve it, we try to get the x by itself. So we try to isolate the x squared first, get the x squared all to one side. If it's got a number in front of it, divide it out so that the x squared is all alone. And then, like you guys said, then you just have to take the square root. When you have that square root, though, anytime you square root both sides of a problem, that's when you get the plus and minus answer. So don't forget to put plus and minus. Hey guys, plus and minus, That's just a lazy way of saying positive 9 and negative 9 without writing the 9 twice. So that's why we put plus and minus. So this stuff is pretty straightforward. It's pretty basic. Trying to get x squared by itself, so we would add 4 to both sides. These cross out. So we're left with x squared equals 4. We square root. So we end up with x equals plus or minus 2. So there's our answer. The next question. The reason why I made the next question is because I want you guys to understand that these numbers don't have to always end up as perfect squares. And what that means is, like, when you square root it, it's not always going to work, and that's okay. So in the next example, I have x squared minus 10. We're going to add 10 to both sides. So if I have x squared equals 10, now I'm ready for the square root step. I square root that stuff. I end up with x equals plus or minus. Well, no, that's what I was about to talk about. When we do this stuff in the calculator, we don't actually care to use the decimals. We will just use them. We'll write them using the square root still. So if the calculator has a square root in it, just write what it says. So this is still plus and minus, but it's just going to stay as square root of 10. What's that? Yeah, we just leave it because square root of 10 doesn't have a nice answer. It's a long decimal, so we just leave it like that. Okay, next page. A lot of these problems, and you know what? I think I'm going to adjust this problem just a little bit. I'm gonna make it so that it looks just a little bit different. So I'm gonna, instead of a 0 there, I think I'll do a 10. These problems, they're not always going to say equals 0. In fact, these problems, they're not always just going to have a single x squared. So over here, I'm just going to put, what can I put? Let's put plus 10x squared. So you could see problems that have x squareds all over the place. But the fact of the matter is, we're still going to use the same procedure because that's the only type of x that it has. So if this had an x squared and a different kind of x, like x to the first, we would not be able to do this. We would have to use a different method. And we haven't learned any other methods yet, so we would kind of be stuck in that situation. So in this problem, got stuff all over the place now. Our goal is to first sort through the stuff, get all of the x squareds to one side, get all of the numbers without the x squareds to the other side. And it doesn't matter which way you move stuff. In the end, it'll all be the same anyways. I'm going to take the 10x squared. I'm going to subtract it over so it goes over to where the 25 is. So I'm going to subtract 10x squared here, and I'm going to subtract 10x squared here. So this gives me 15x squared. Then I still have the minus 7 equals 10. So if I got all of my x squareds to the left, I want to get everything without the x squareds to the right. So the minus 7 needs to go. So I'm going to add 7. So I have 15x squared equals 17. Then my next step is to divide by 15. So we're doing all of this work because we're trying to get the x squared all alone. So we have x squared equals 17 over 15. And now finally, since the x squared is all by itself, now we can square root it. Now guys, when you draw the square root, make sure you cover the entire fraction. For example, if you wrote this, that means something totally different. That radical has to cover the entire thing, both the top and the bottom. As a matter of fact, when you guys type this in your calculator, you're going to see something weird kind of happens. So I'm going to need your help with that. X equals plus or minus. Someone type in. So you want to hit the ABC button after you've hit the square root button. So hit the square root button first, and then hit ABC. Put 17 on top, and then 15 on the bottom. So we end up with this. 15 is regular, right, on the bottom? And then on top, what do we have on top? Square root of 255. So what the heck just happened? Let me tell you a rule about radicals. In math, well, remember Donna just a few seconds ago, she tried to tell me this decimal? That decimal is a never-ending decimal. It's called an irrational number. In math, you're not really supposed to have those types of numbers on the bottom of your fraction. So there is a thing that the calculator does called rationalizing the denominator. It does all the work for us, but I'm going to show you let me show you a simpler version. I'm going to use numbers that are a lot smaller so you can see like what the calculator is doing. Let me do it off to the side here. So we'll talk about rationalizing the denominator. Rationalizing the denominator. So here's what happens. Let's start off with something just very easy. Let's just say it's like radical 3 over 2. So this is all stuff that was talked about a long time ago, and everyone always forgets about the rules. So when you have a radical that covers your whole fraction, that means actually there are 2 separate radicals. So it goes like this instead. We can break it up into 2 separate radicals. But if you remember what I said, the bottom is not supposed to be a radical. So here's how we fix it. I'm going to change colors so you can see the step that happens in the calculator that we can't actually see. What's happening is, if I want to get this radical 2 to disappear, I multiply it by itself. Because a radical times a radical basically cancels itself. So on the bottom, we end up with 2. So if you look at our problem over here, that's where this 15 came from. The calculator does radical 15 times radical 15. Now, here's the issue, though. It's not fair to just do it to the bottom, so we also have to do it to the top. So when you multiply radicals, since they both have radicals, you can actually multiply them. So that's why this turns into a 6. That's where 255 came from. I guarantee you 17 times 15 is 255. So this is the stuff that the calculator is doing. So when you see that number change, just write down what it says, because it's doing it right. You didn't type it wrong. That's just the way it's supposed to be done. Let's see. I want to make one up for you. I don't like this example. There's too many that are equal to 0. Let me just make one up for you. Let's do 2x squared. Let's do plus 4. And let's do equals 4x squared. And let's see, what do I want to do? Let's do minus 16. I'm going to do this one with you. So just like before, you got x squareds all over the place. Get them all to one side. So it doesn't matter which one you move, but I like moving them to the left just because I like that Beyonce song. So I'm going to subtract 4x squared. Subtract 4x squared. So you guys can't hear this, but in my head I'm going to. Sorry. So that leaves us with negative 2x squared plus 4 equals negative 16. So since I got all of my x squareds to the left, I'm going to take the positive 4 and move it to the right. So this is negative 20. Now the next step, divide by negative 2. So we have x squared equals 10. And now we're going to take the square root of both sides. So guys, don't ever take the square root if it still has the number in front of it. Like the number that's stuck to it, you have to divide it out first. You have to get the x squared completely alone, and then we can take the square root. So our final answer ends up being plus or minus. And we already did this one, right? Square root of 10 is just square root of 10. So we can just leave that alone. And that's pretty much it. That's what your entire assignment for today is going to be about. I'm also going to say this. I've been playing with the big ideas math stuff a little bit. I don't need your cards anymore. I'm going to let you guys keep your cards. I found a way to see everyone's username. So if we ever pull it up in class and you don't know, I can just look it up. So I'm going to let you guys pick up your cards, keep them in your binders, because there is also a big ideas part to this. I'm going to look up how many questions, I can't remember. It's always going to be between 3 and 5 questions, though. So the rest of the time is yours. You've got over 30 minutes to work on assignments. What are we in, 3.2? So since there's a lot of time, we're going to do all of them again. And as you guys are working, I'm going to make the answer key and post it on the wall. When you guys get to the back, put this up. When you guys get to the back, there's going to be some triangles in there, and it's going to tell you to use Pythagorean theorem. So that's the formula. You may want to jot it down on the second page. And then I put up the big ideas math questions also.